Hi and Assalamualaikum everyone. This is our video presentation for Material Balance Project ECH3123. Our task is to design the system for the production of hydrochloric acid. We are from Group 12. Alright, next I will introduce our members. So first, me, Muhammad Bahaki bin Muhammad Abdul as a leader. Next, Amira Shazana binti Samsuri as a scriber. Aidil Shukri bin Muhammad Ali, member, and last but not least, Kampushain or Amy as a member. Alright, let me introduce you about what is actually HCl. HCl or hydrochloric acid is a colorless watery liquid with a sharp irritating odor. It consists of hydrogen chloride, a gas dissolved in water. Its melting point is in about negative 26 Celsius, and its boiling point is 108.6 Celsius. So, what is the uses of HCl? So HCl, usually we use it for purification of table salt, used in to control the pH level, regulating acidity of solution, and we use it to remove rust or stain from metal. Next for the method, what we use to produce HCl, we use Manningham process relate with a fluidized bed reactor. For the condition, the feedstock we use is sodium chloride and sulfuric acid, NaCl and H2SO4. The production for per annum is 0.1 million ton. The purity that we need is 99% vapor HCl and 37% liquid HCl. The method we use is Manningham process. It is an industrial method in producing hydrogen chloride HCl gas, involved in using a Manningham furnace or fluidized bed reactor. The catalyst we use is sand. Uh, what is more important is it is environmental consideration, and it not produce large amount of waste and pollution that is bad for the environment. There are a lot of substance or material we use to produce hydrochloric acid. So I will tell and talk about hydrogen chloride. So for the material safety data sheet of hydrogen chloride, it gives a lot of danger, such as hydrochloric hydrogen chloride is corrosive to metals. It gives effect to skin like corrosion and irritation, and it also damage serious for eye, like eye irritation. How we handle it? So first, we need to avoid breathing mist or vapor when handle it. Wash skin thoroughly after handling it, and when you use it, use only outdoor or in a well ventilated area so that it could not damage others. How we storage it? Uh, when you storage it, you cannot use metal containers because it is dangerous, and it will corrode the metal. And when you storage it in the container, you need to close it tightly so that it not vapor to the surrounding and affect others.
Next is the MSDS of sulfuric acid. Sulfuric acid has the danger in it is corrosive to metals, cause severe skin burn and eye damage. We can wear protective gloves, protective clothing, and eye protection as prevention when handling sulfuric acid. Lastly, sulfuric acid have to be kept in a tightly closed and dry container.
Next is MSDS for sodium chloride. The dangers involved are release of irritating gases and vapors. Secondly, it can also cause ignition. And lastly, sodium chloride can also cause dust formation. To prevent the dangers, we must wear full protective gear and also wear self-contained breathing apparatus pressure demand. Lastly, for storage, we must protect them from moisture. To protect them from moisture, we can simply keep it in a container tightly closed in a dry, cool, and well-ventilated place.
Now I will present about NaHSO4. So what is NaHSO4? So NaHSO4 is called by sodium biosulfite, which is an acid salt formed by a particle neutralization of sulfuric acid. At this part, I will present about MSDS of NaHSO4. So I have a three part, which is danger involved, prevention, and storage. The first thing is danger involved. It will specify target organ toxicity. Second, it will make your skin corrosion or irritation, and then it will serious respiratory damage. Next, prevention. So how to prevent when you the part of the things. So first is avoid inhalations of dust or mist. Second, use a respiratory ask if a airborne dust or mist may be generated. And last one is the most important: wear protective glove, protective clothing, eye protection, or face protection. Next, storage. We need to keep container tightly closed in the cool, well ventilated place, or and keep container dry. Now we go to the Na2SO4, which we call sodium sulfate. So sodium sulfate is inorganic compound, and all form are white solid that are highly soluble in the water. So I will present about MSDS of Na2SO4. So it the same part, which is danger involved, preventions, and storage. So the first thing is danger involved. It will cause irritation to the respiratory system if inhaled in a large amount. So the second one is prolonged exposure to high concentration of sodium sulfate, thus may cause respiratory irritation. So the next is prevention. How to prevent when you enter the part. So the most important things is we need to wear protective equipment. And then when you done use sodium sulfate, you need to transfer to a disposal container. And when you enter the factory or something else, you need to ensure educate ventilator when you want to process the sodium sulfate or you want to make the sodium sulfate. So the last one is storage, where you need to tightly seal to prevent moisture from contaminating the substance. And then you need to store in a cool, dry, and well ventilated area. And sodium sulfate is hygroscopic.
For the overall process, sodium chloride and sulfuric acid will enter the gas, liquid, and solid fluidized bed reactor, in which three streams are produced according to the physical states. Sodium chloride and sodium sulfate will exit as solid. Sodium bisulfate exits as liquid, while H2SO4 gas and HCl gas enters the cooling tower to reduce the temperature before entering condenser 1. Most H2SO4 gas will condense into liquid, while some of it remains as gas and exit condenser 1 with HCl gas into the absorption column. A stream of water enters the absorption column to absorb HCl gas into hydrochloric acid. H2SO4 gas and HCl gas and also some water vapor enters condenser 2. In condenser 2, H2SO4 gas, HCl gas, and water vapor will condense into liquid, while some of it exits the condenser in gaseous form.
So the first unit for the production is a fluidized bed reactor. So the basis we use is 100 mol per second. For the input stream, as you can see here, the input consists of zero point 0.5 mol NaCl and zero point 0.5 mol per mol H2SO4. So because we use the basis 100, the molar flow rate for NaCl and H2SO4 both is 50. Next, for the output stream, we have three output stream because this is the fluidized bed reactor. It can differentiate it with their phases. As you can see, stream 2 consists NHSO4 in a liquid state. Stream 3 consists of H2SO4 and HCl in a gas state. And stream 4 consists of Na2SO4 and NaCl in a solid state. So because this reactor have two chemical reaction, so we calculate it using extent of reaction method. So as you can see here, for the extent of reaction, for the first equation, NaCl plus H2SO4 equal to NaHCl and HCl, the value of the extent is 25. And for the second equation, NaCl plus NaHCl4 produce Na2SO4 plus HCl, the extent value is 15. Alright, so uh, when we calculate it, as you can see here, the conversion for H2SO4 is 50% and the yield production is 80%. The yield is the what the substance we want. So the desired substance we want is HCl. So as you can, because of that, we can calculate it. As you can see in the Excel, the production of HCl produced is 40 mol molar flow rate.
Okay, I will explain the condenser one. So this is the first one. The part one is blow diagram for condenser. So we use the Payazab formula, which is Ross law. So condenser here we have three unknowns, which is N2, S1, for S2, 1 minus Y. So 1 minus S1. So for string 2, we have N1, and then 100 more per second is the feed or basis fit. So to separate, so we need to find the DOF first, DOF. So we have three unknowns. For unknowns, we have three unknowns, which N2, S1, and N1. So independent species balance, we have two species balance, which is H2SO4 and HCl. So other relation equation, I have a one -1 because what we I have put the basis area, so I cannot enter the basis area. So I just get for one only is a Ross law. So separation hierarchy separate from light to heavy. HCl for boiling point is -85, and the H2SO4 boiling point is 337. So we can see that HCl is a high light key and H2SO4 is a heavy key. So now we go to calculation. In the stream one, we have a total mole for 100 mole per second, and then mole flow rate just mole fraction times with mole feet. So how to get the partial pressure? Partial pressure equal to mole fraction times with P total, which is we said the P total pressure is 760 millimeter mercury of. So we get the so we get the value, and then for pressure at a certain temperature, we use the Roslow formula. So we just get and then we get the formula. So for the S, how to find the S is partial pressure divided by pressure at a certain temperature. So at here we need to total for S must be 1. So at here we for entering constant we just reference by website at so you can see the reference at the Excel. So for the stream 2, how to calculate the mole of at the stream 2. So 100 times with molar flow rate at the stream 1 equals to stream 2 mole fraction and N2. So and then we get the 50.002 something s. So we get the temperature 387.8314 celsius. So for the stream 3 we just calculate manual, or we just put the formulas, and then sulfuric acid at the liquid phase I get 49.97992.
In the absorption column, it is used to absorb HCl gas into hydrochloric acid by adding water. The pressure is 1.013 bar and the temperature is 30 degrees Celsius. Four assumptions are made, which are solubility of HCl gas is 673 gram per liter at a temperature of 30 degrees Celsius. The efficiency of HCl is 90%. The mass fraction of H2SO4 gas and HCl gas that enters absorption column is zero point 0.4 and zero point 0.6 respectively. The mass fraction exit will be 0.37 for HCl liquid and 0.63 for water. First, we will have to find the mole fraction for HCl gas, H2SO4 gas that enters, and HCl liquid and water that exits. To find the molar flow rate of H2SO4 gas and HCl gas, we will multiply the mole fraction with the basis, which is 100 mole per second. The solubility of HCl will be used to find HCl gas in stream 3 and HCl liquid in stream 4. We can also find the molar flow rate of water in stream 2 using solubility as well. By using molecular species balance, we can find the remaining molar flow rate.
For condenser 2, the intent is to separate liquid and gas. In stream 1, the basis used is 100 mole per second. It contains 0.2 mole percent HCl, 0.4 mole percent H2O, and also 0.4 mole percent H2SO4. So each mole flow rate 20 for HCl, 40 for H2O, and also 40 for H2SO4. For stream 1, to calculate the temperature is by using Rod's law in Excel, using a solver with the pressure set to 760 millimeter mercury. We get the temperature for inlet stream is 344 degrees Celsius. And for stream 2, since the recovery of HCl is 90%, we can calculate the number of mole for hydrochloric acid, which is 0.9 times 0.2 times 100, we get 18 mole. From that, we can also calculate the mole flow rate for stream 2, which is N2, by dividing 18, which is the number of mole of hydrochloric acid, and divide it by 0.99, we get 18.18. And for stream 3, to calculate the mole flow rate, we can simply use total balance. 100 equals to N2 plus N3. Since we already get the value for N2, to get N3, we must subtract 100 with N2. So we will get N3, which is 81.82. For the value of x1, x2, and x3, we will use Rod's law, where to calculate the value of x is by dividing PA y P total, which is the mole fraction, times the total pressure 760 divided by the vapor pressure of each substance, which is HCl, water, and H2SO4. For x1, which is the mole fraction for HCl, we get 0.003. And for X2, the mole fraction for H2O, we get 0.0014. And lastly, for X3, mole fraction for H2SO4, we get 0.99.